Welcome back. Problem 6-77. So statement is beam is subjected to an internal movement of 2 kips into feet. Determine the maximum tensile and compressive stress in the beam. Also sketch the bending stress distribution over the cross section. So you can see this is the cross section of the beam and that movement is applied on that. So you have to find the compressive stress, maximum compressive stress and maximum tensile stress in the beam. The moment that is given is 24 kips into inch. So let's start with the solution. So we know that maximum stress is equal to m into c divided by I. So we do not have I, but we have the cross section and all the data. So first we will find this I. So for this I, for finding moment of inertia, for finding I, we need neutral axis. We need neutral axis, and what will be the location of neutral axis? For that location we have the formula y bar is equal to sum of y dash into a divided by sum of area. Now you can see that we have uh, let this is 1, this is also 1, this is 2, and this is third plank. So what we will do is that we will take this base as a reference and we will find the moment neutral, the location of neutral axis from this base. So let's start. So y dash is equal to the first one. So the area of first one is 3 into 1. So this is 1 inch and this height is 3 inch. So 3 inch into 1, and this is the area, and y dash is the distance from the base till the centroid of this, and this will be equal to 1.5. And what we will do is, since we have two portion of 1, so 2 multiplied by the area is 3 into 1, and its y dash will be 1.5. Clear? So 1 point, not 0.15, multiply by 1.5. Okay, plus now this area. So this area, you can see the area of this will be equal to 1 multiplied by this 8. This total is 8. If you add them, this will be 8, and its distance from the base till the mid of this will be equal to 3.5. You can see this is 3 and half of this will be 0.5, so this will be equal to 3.5. So I will write it, the area, which is 8 into 1 multiplied by y dash, which is 3.5, plus this area. So you can see this area is 3, and this area is 1 multiplied by 4, and its centroid will be at a distance of 2 from this. So 2, and from here, from this base, it will be equal to 6, because 2 plus 1 plus this 3 will be equal to 6. So I will write y dash is 6 multiplied by its area, which is 4 multiplied by 1, and divide by sum of all the areas. So the area of, we have two areas of 1, so 2 into 3 multiplied by 1, plus second area, which is equal to 8 multiplied by 1, plus third area, which is equal to 4 multiplied by 1. And when you solve this, you will get y dash will be equal to 3.3889 inch. So this is y dash. So what we will do is that we will locate this y dash. For that I will remove this. So y dash is at a distance of 3.389 from this base. So from this base, this will be its neutral axis. This will be its neutral axis. I will write neutral axis. Now we'll find moment of inertia for this by using parallel axis theorem. So we will write parallel axis sum of I dash plus AD square. Clear? So we will write first for this one, for these two. This is 1 and this is also 1. So we will get the moment of inertia of this one and we will multiply it with 2. So moment of inertia of this portion about this neutral axis is equal to 1 over 12 its breadth and this height cube. Clear? Plus AD square. So this area and distance from neutral axis till the center of this section. So this is your D. So I will write it 1 over 12 into its breadth which is 1 and height which is 3. So 1 into 3 cube plus this area which is 1 into 3 and D square. D is this distance. This is the neutral axis which is Y dash and this Y dash is 3.389 and if you subtract the half of this, half of 3 which is 1.5, so Y dash minus 1.5 and Y dash is 3.889. So when you calculate it 3.3889 minus 1.5 will equal to D. Okay, so we will write it 3.3889 minus 1.5 square plus moment of inertia of this body. So its breadth is 8 and height is 1. So 1 over 12, 8 into 1 cube plus this area which is 8 into 1 and its distance from neutral axis till centroid. So you can see this is this distance is 3 point, this is Y. Clear? This is your Y and this distance from the mid of this till this is 3.5. So 3, if you subtract 3.5, if you subtract Y dash which is 3.5 minus 3.388, so you will get this D. This small portion is D. So I will write it 1 over 12 8 into 1 cube plus this area 8 into 1 and 3.5 minus 3.3889 whole square plus the moment of inertia of the third portion. So this is the moment of inertia. So its width is 1 and height is 4. So 1 over 12 1 into 4 cube plus this area which is 4 into 1 and its distance, if you subtract the half of this will be at a distance of 2 from the top as well as from the this portion 2. So 2 and this total height is now 6. So if you subtract Y from this is Y dash. So if you subtract 6 minus Y dash which is 3.388, it will give you the D for this portion and this D will be this distance. This will be the D. So I will write it 1 over 12, breadth is 1, height is 4 cube plus 1 into 4 into 6 minus 3.3889 whole square. So when you solve this, you will get the moment of inertia of this whole cross section about neutral axis comes out to be 59.278 inch power 4. Okay. Now you have I as well. So we will move toward maximum bending stress. So maximum bending stress. So as we know that due to this movement there will be a compression in upper portion while there is a tension in below portion. So maximum stress due that is compressive is equal to M into C divided by I. So movement is not available. Clear? Sorry, movement is given. A movement is 24 kips into inch. So 24 into 24, maximum stress is 24 into C. Now what about C? C is distant from the top and neutral axis, and this distance is C. Clear? And this C is equal to total height is, you can see total is 8. This is 8. So if you subtract this distance, which is y dash, so if you subtract y dash from this 8, that will give you C. So I will write it. C is equal to 8 minus 3.3889 divided by I, which is 59.278. So this will give you 1.87 KSI. Similarly, maximum bending stress due to that will create tension in below portion is equal to M into C divided by I. So M is 24. Now C, this distance from neutral axis till the bottom one, which is equal to y dash, and y dash is 3.3889 divided by 59.278. So you will get 1.37 KSI. Now we have solved out the first portion, so we will now plot the variation. I will write here the maximum stress due to compression is equal to 1.87 KSI, and max stress due to tension is equal to 1.37 KSI. So this is the stress at, if I choose another color, so this is the stress at this portion, sigma C, and this sigma T is stress at this portion. Now what about the stress in this portion and in this portion, because we are going to plot the variation. So for that I will find these stresses as well. So bending stress at y is equal to 0.6111 and y is equal to minus 0.3889 inch will be plotted. Why we are taking 0.866? So total is this distance is 0.661, because you know that this total is 4. So if you subtract y dash from 4, you will get this 0.661. And this portion, I will choose another color, the red one. This portion will be equal to 0.3889. We will take it minus because this is downward and this is upward, and we will find the stress at this portion. So you can see stress at y is equal to 0.611 inch is equal to M, this is minus my divided by I. So M is 24 minus y is 0.611 divided by I, which is 52.278. That will give you minus 0.247 KSI. So it means that the upper one is in compression. Clear? Similarly, sigma at y is equal to 0.3889, that is minus, and when you calculate it in using formula sigma y at 0.3889 is equal to 24 into minus 0.3889 divided by 55250. This is 59.278. So you will get it 0.157 ksi. So this is positive, so it means that this is in tension. So what I have, you have to remember minus 0.247 and plus this one. So we will now plot the variation. So at this portion you can see that stress is maximum. So let this is the stress. The variation of this stress is like this at this portion. And at neutral, at this axis you have a stress of 0.247. This is 0.247, that is in compression, and this is also in compression C. So here you will have but not 0, so the stress variation will be like this one. And here you have a stress of, this will be also not 0 but there will be positive, and this stress is 0.517. And here you have maximum stress. So the variation will be like this. It will take some time, but it's better to understand over here. So this is the stress distribution. Now here this is in compression, so the arrow sign will be here. All this will be in compression. Here at neutral axis it will be 0, but here you will now have this one tensile, and the stress variation will be like this one. I hope you are getting the idea that what I am doing. So this is the stress variation. And this was all about problem 6.77. I hope you have enjoyed this video, and if you think this is difficult one, so I will suggest you to practice it again and again so that you can understand it whole in a whole. Again, if you have any question, you can ask me in comment section. Thank you for watching.